Good afternoon, everyone, and welcome to number 5 of our Nichi Go Global and J-Bridge webinar series, brought to you by Jetro Sydney and proudly supported by the AJBCC, the state government offices here in Japan, and our colleagues on shore. Thank you very much for tuning in. Language interpretation is available today, so please click on the globe icon to listen to the webinar in Japanese. And thank you in advance to our 2 terrific interpreters. My name is Sally Townsend and I'm South Australia's representative for Japan and Korea, based here at the Australian Embassy in Tokyo. And today it is our turn to take the lead with the fascinating topic of aerospace, AI and robotics opportunities in Australia. We'll hear from 5 companies this afternoon that will give an overview of their technology and an insight into the highly sophisticated, world-leading technology that is coming out of Australia. First of all, I would like to introduce my colleague in Adelaide, Tiffany Kachmar, Director of Defence and Space at the Department for Trade and Investment. Tiffany will set the scene on the exciting sectors of space and defence before we move on to our first presenter. Thanks, Tiffany, over to you.
Thank you very much, and it's lovely to see everyone, and thank you so much for this opportunity to talk a little bit about South Australia. I am going to share my screen, if you could please bear with me. Wonderful. I hope that you can see that on your screen.
Yeah, we can see your slide.
Perfect. Thank you so much. So as Sally said, my name is Tiffany Kachmar and I work for the Government of South Australia, as Sally does as well. And I work within the Department for Trade and Investment, and I look after the defence and space sectors here. Firstly, I would just like to acknowledge that I meet today and I meet you from the traditional lands of the Kaurna people, and that we respect their spiritual relationship with their country. So I work in a really amazing area in South Australia. South Australia is a very innovative, a smaller size city where we are really very much leaning into areas around high tech and certainly around new space and the opportunities that exist. And myself and my team, certainly working with our overseas offices, our role is to grow the economy of South Australia by increasing investment into these key priority sectors, and also increasing exports that will grow our existing sectors of priority. I'm just going to talk a little bit to the space industry. As Japan is very, very well aware of the great opportunities around the space sector on both the more traditional side of space, as has been traditionally used by defence and government, but certainly on the more commercial, emerging new space sector, which is certainly our focus. So you can see here just some statistics. This is a very emerging sector for us. We do have a big history in South Australia with the space industry, having the Woomera test range here. That continues to be a very, very busy test range for defence purposes. But on the new space side, it is very much an emerging area. At the moment, that area is contributing $166 million to the economy, employing about 1,500 people, but really importantly, a huge growth rate, certainly faster than other areas of the economy. And you can see that stat there of 64% growth per annum over the past 4 years in terms of companies emerging in South Australia. And it might be interesting, and of course we would always welcome participation in the amazing Australian Space Forum that we host in South Australia twice a year at the moment. It started with a very small presence, but we've grown to attendance of over 1,000 people when we run this. And I think we had over 100 exhibitors in the last forum. So certainly this is where the entire new space ecosystem in Australia comes together in South Australia for this event. And we also often welcome people internationally, international speakers, and it's certainly a great opportunity if this is a sector of interest to you. Key pillars of growth around the new space sector for us. Across the top, we have 3 key goals. The first one, of course, contributing to Australia's national space strategy. So we have an Australian Space Agency that we have only had for about 4 years now. Obviously works very closely with JAXA and has a memo of understanding with JAXA. So certainly South Australia looks to contribute very much to the national agenda. And particularly around some of their pillars relating to access to space. Launch is a very interesting area for us. Supporting positive norms for space actors. Japan is acutely aware and participates very much in being a responsible player in space, and Australia aspires to do so as well. And certainly initiatives such as the Artemis project, the NASA Artemis project, Australia has lent into. And for example, we're looking to see where we, as a state of South Australia, can really add value to the Artemis project. And one of those areas is food production in space. So we've just recently had a $35 million program research project approved that will be led out of South Australia about advanced food technologies and production techniques. The second one there, capitalise on the opportunities presented by new space. So of course, many small connected satellites in low Earth orbit, providing data to all industry sectors, of course, government, defence as well. But very much we're focused on the commercial opportunities of what space data can offer to agriculture, to mining, to transportation, to energy, and really every sector, certainly in Australia, but across the world. And certainly machine learning and artificial intelligence to really exploit and add value to space-derived data, and certainly the combinations of bringing data from different sources together and providing it for decision making to industry is particularly of interest to us. And of course, cultivating South Australia as a centre of gravity. So South Australia is really known in Australia as the defence and space state. Obviously, those two things fit very nicely together. But of course, we're also recognising the more commercial opportunity of space as the technologies emerge and become more affordable and accessible. So certainly workforce is something that we're very focused on. Supporting a really innovative ecosystem is really important, and I'll show you a slide on our space and defence ecosystem at the end of the presentation. Supporting infrastructure, this is a key one. Everyone knows that space is very expensive, so government is certainly leaning in to see how we can assist industry to scale in this really important sector. And of course, growing a globally competitive industry, defence and space, and particularly space, you have to look at this with a global view, not with an Australian view. And certainly creating an ecosystem and an environment with infrastructure that is attractive for companies in both the upstream part of the space domain and the downstream data part to invest here in South Australia. And we've had great companies coming to establish here, which is wonderful. Just touching base on the defence side, just by comparison, you can see here that certainly South Australia has very strong credentials. There are significant programs, particularly around naval shipbuilding and particularly around cyber and intelligence that are driven out of, and also aerospace that are driven out of South Australia. So it does make a big contribution to economy and to our GSP, as you can see there. Certainly a large number of jobs, a large number of investment is being attracted, and a good export result as well. And we have currently over 300 companies in defence companies in the sector. And we also have 7, I believe, of the 10 major primes, defence primes around the world have a significant presence in South Australia. We also have access to world-class test and evaluation facilities, and that's just a little snapshot there of Woomera, as I've mentioned before, is very much home to our beginnings in the space sector, and a number of test activities occur at Woomera, and Coltana Test Range, Port Wakefield, and also on the commercial side, we're developing some commercial launch facilities in partnership with industry. So Whalers Way, which is number 4 there, is proposed to be our orbital launch site for access into polar and sun synchronous orbits for rockets, and obviously to deliver Earth observation and a range of different sorts of small satellites from that spot there. And Kaniba in number 5 there is our suborbital test, commercial test range. So we've already done some launches from Kaniba, and we have some test launches out of Whalers Way coming soon. So I'm sure that you will see more detail on that soon. The other really important thing is to talk about our innovation precincts a little bit further. And on the right-hand side, you can see the Adelaide is our capital city. You can see the CBD there, and you can see the Osborne Naval Shipyard, where the Collins class and the frigate program are delivered from. You can also see Edinburgh in the north there, the Defence Precinct with our Defence Science and Technology Group. The largest presence of that group in Australia is located there. You can also see Technology Park, where many of our key defence companies have established. And down the bottom, you can see Tonsley Innovation District, a really important advanced manufacturing and technology centre for us. Just recently securing funding around a Factory of the Future project with one of our universities, and also with BAE Systems, particularly around naval technologies, which is fantastic, a bit of a testbed area. And Lot 14 in the middle there, located in the CBD, is our really, really significant CBD innovation district, focused on defence, space, artificial intelligence, creative industries, and also cyber. So we have many institutions, universities, defence, and startup companies and larger scale companies all co-locating around Lot 14, and this represents a really good opportunity for companies looking to break into the Australian market. I'm not going to touch too much on this, but we do certainly align very much with the federal defence priorities. So Australian Defence, Department of Defence have certainly highlighted around the technology area, some of these areas that you can see up on the screen as very much future-proofing for defence. These are the future force capabilities that are required. These happen to be areas where South Australia has a really great value proposition, and we really want to capitalise and grow these areas with really smart companies from around the world. Again, this just flows a little bit further from what I just showed in terms of the federal approach. Certainly in terms of priorities for us, naval shipbuilding, the guided rockets and payloads, cyber products and training, electronic communications and sensing, and of course what we're talking about today, robotics, autonomous systems and AI are absolutely critical pillars for us in South Australia, and really based on advanced technologies around cyber, electronics and quantum. Quantum is something that we have been spending a lot of time on very intensively over the last year to 2 years to grow our capabilities here. And I have here just a snapshot of, it's not showing everything, but it is a snapshot of both our defence and space ecosystem. Probably, certainly on the space side, this was 5 years ago, much smaller than we have been able to now achieve. And there are companies here across all of those pillars that I've talked to today, and certainly companies that are very open to working with companies all over the world. So this gives you a snapshot, and certainly we're happy to assist with any connections or introduction points where these may be existing partners or these may be partners of interest to you. Thank you so much. That wraps up my presentation, and I will stop sharing my screen. Thank you.
Thank you very much, Tiffany. And it's amazing to see how much the space industry has grown over the past 5 years. Our Japanese viewers today will recognise Woomera, and Woomera, of course, is where the Hayabusa 2 sample capsule landed at the end of 2020, safely retrieved by JAXA, and of course with collaboration from Australia on the whole and South Australia as well. So thanks, Tiffany, that was terrific. I'd like to introduce our first speaker, and he's from South Australia. Very proud to introduce Dr. Zygmunt Spack, who is the Executive Director of Insight via Artificial Intelligence. Go ahead, thank you.
Thank you very much. Thank you for extending the invitation to speak at the JBridge webinar today. It's a great honor for a company to be able to speak to all of you today. Our company, the mission of our company, is to help humans and machines work together in smarter ways. And we do this by building explainable and trusted artificial intelligence solutions. We have deep expertise in the company. We hire people that have PhDs in mathematics, computer science, as well as engineering. And we work at the leading edge of research and development in fields such as explainable artificial intelligence, machine learning, computer vision, natural language processing, as well as virtual and augmented reality technologies. We can build custom AI data solutions or use industry standard platforms such as Amazon Web Services. We have a unique product that I will describe in more detail towards the end of the talk, but the product is aimed to help you plan, build, and manage your AI systems profitably, but also ethically and responsibly. Our company also offers education and training. For example, we have an education course targeted at executives and board members that teaches you how to identify the best opportunity for AI within your organization, how to determine the return on investment.
Gilmour さん、let me cut in. 通訳さん、日本語チャンネルで英語が出てます。日本語の方がミュートになってるので、ちょっと見て。はい。Sorry, this is a problem of the interpretation. No, it's okay. I solved. Thank you very much.
Okay, thank you. So we also offer education and training courses. For example, we have education courses which are aimed to help people understand how to adopt AI within the organization, how to determine the return on investment, and also how to determine the impact AI will have in their organization. Our specialty is in developing real-time adaptive AI systems. We have efficient techniques for incrementally updating and transmitting AI models. And this means we can build interactive systems that are unprecedented. The human can really interact with the AI system. We can also apply our solutions in limited bandwidth scenarios. For example, we can take a deep network of 160 megabytes and compress it down to less than 1.3 megabytes without any accuracy loss. This has obvious implications in space, where you might want to transmit a complicated, sophisticated model, but you have very limited bandwidth to do so. Our innovations allow us to work on exciting new applications. For example, we are working on explainable anomaly detection for computer network security applications. We are also working on human integrated sensor systems. We are talking about things such as the Apple Watch or the Fitbit or the Oura Ring, things that can measure the body temperature, the heart rate, etc. And we are developing algorithms to determine the onset of infection from this kind of data, which is clear applications in the aged care sector, where we need to look after people and have an early warning whether their health is deteriorating or not. Another specialty of ours is explainable artificial intelligence. Most AI vendors offer AI capabilities with only basic explanations. They can answer questions such as what kind of data does the system learn from? What kind of outputs does it give? Or maybe they can say something about the performance of the system on some test set. But these kinds of explanations are not enough for real human-machine teaming. A person really needs to understand more about why an AI system has made the prediction that it has made. They want to understand what features led to the system's prediction. Why did the system not predict something that maybe you were expecting it would predict? What would have to change about the input for it to give the prediction you expect? What if the input was slightly changed? How would it affect the confidence of the system? The questions on the right-hand side demand an interactive system where the person can really dig deeper and understand the implications of what the AI system is doing. And this is why we have such a great focus on real-time adaptive AI systems. Our company philosophy is that we develop technology with a human-centered paradigm. We believe that human actors and human actions form an integral component of system operations and goals. This means that we view everyone as a someone and not a something. Employees seek autonomy, mastery, and development. We want to thrive as people in the workplace because the workplace and work itself serve as one of the most important social channels through which humans can flourish and human dignity can manifest. But when one introduces an AI tool into the workplace, it implicitly or explicitly occupies a position on the social structure. And we need to be aware of this, and we need to take this into account when we are deploying technology. Here are some example projects that we are working on. For instance, we have a bike with 2 sensors, and with these sensors, we can detect the distance between a car and a bike, and we can determine whether a car is passing the bike or if the bike is passing the car. And this means we can take this information and put it onto a map for the Road Traffic Authority. So we can start to see where in the city do we have problems with road infrastructure, where the cars are coming too close to humans, where there could be a potential for an accident. This kind of technology is a great example of Society 5.0, of data-driven decision-making to inform how we build our society. We also develop virtual and augmented reality training simulations. In the top left-hand corner, you will see a training simulation we developed in collaboration with Aboriginal healthcare workers. And the aim is to train Aboriginal communities how to manage diabetes-related foot complications. Diabetes is a great problem in the Aboriginal community, and there isn't enough expertise to manage the wounds. With this tool, people living in remote communities can upskill themselves and be empowered to manage the health problems that they encounter. On the top right-hand side, we have an example of us developing a training simulation for people living with intellectual disabilities. Here, we are trying to teach basic life skills, how to prepare a meal, for example. The aim is to give people the ability to live more independent lives. We offer an all-in-one collaborative platform which assists organizations to plan, to build, and to manage AI and related autonomous projects. The platform provides a systematic whole-of-organization approach to planning, building, and maintaining an AI system throughout its entire lifecycle. This software tool helps you identify your best opportunity for AI. Let me show you a little example. In this process of adopting AI, you will go through 3 stages. You have to plan, you have to build, but once it's built, you also have to manage the continuous life cycle of this tool. In the first stage, you might want to determine what should you actually solve, what will give you the best return on investment. And this collaborative tool allows everybody to come together and identify problems. In this example, we decide we want to detect the onset of infection from a wearable device. And we can quickly determine who needs to be involved in such a project. In this context, it was a defense project. So we have the medical scientist, the doctor, the infantry, and so on. And you also think about what tasks do these people perform in their roles? And how long do they spend performing those tasks? In this instance, the medical scientist spends 50% of the time doing clinical studies and surveillance. And so you can start to see if you can automate this process, what the potential return could be. But there might be other benefits, such as improved accuracy, consistency. With this tool, you have a systematic way of thinking through all the implications of the technology. Of course, it's not enough to think just about the financial questions. In a systematic way, we have you think through what the human impacts will be. For example, we have a summary of the different people that will be affected by the tool and a summary of how it might affect them. When you go into more detail, you start being able to see that people have to answer 3 kinds of questions. How will this tool affect you if the system's operating normally? How would it affect you when it starts making a lot of mistakes? And what will happen if it becomes completely unavailable? And for each 3 of these scenarios, you ask yourself the question, how would it affect the ethics principles, the sense of competence in the workplace, the sense of connectedness, the purpose and autonomy in the workplace? Now, I can only give you a very brief view of the tool because there's a lot to say about it. So I invite you that if you are interested in learning more, to reach out to us and we can speak in more detail about all the different facets of this tool. I want to end by inviting you to partner with us. Let us work together to build Society 5.0 so we can truly have humans and machines working smarter together. Thank you very much.
Thank you very much, Dr. Schbach. That was terrific. I'd like to now introduce company number 2 from Victoria, Moog, with Regional Sales Manager David Shintaro-Morris. Go ahead, David.
Great, thank you, Sally. Could I just do a quick check the audio and video is showing?
Yeah, perfect.
Oh, good, David.
Yeah.
Great, fantastic. And yeah, thanks again, Sally, and the state governments and JETRO for this opportunity. So good afternoon, everyone. My name is David Morris. I'm the Regional Sales Manager here at Moog Australia. I might just start with a bit about myself. I've spent the last 15 years with this company, Moog. It's actually 10 years at Moog in Japan, in Kanagawa Prefecture, and 5 years here in Australia. And I'm currently based here in Melbourne, Australia. So today, I'll be starting with a brief summary of the Moog company, followed by Moog's current activities in Japan. And then I'd like to spend the majority of our time introducing Moog Australia, our capabilities, and where we are looking to grow in Australia and with partners in Japan. So some of you may be wondering, okay, who is Moog? So the company was founded by Mr. Bill Moog over 70 years ago in a small town in East Aurora in upstate New York. Since then, Moog has grown to a global multinational company. And I might just point out that in English, the company name is pronounced Moog. In Japan, it's Moog. We employ about or over 12,000 people in 27 countries. And Moog, we're a designer and manufacturer of systems and solutions involving precision control. So in our aircraft segment, Moog designs and builds the flight control systems for commercial and military aircraft. So key customers of ours here include the likes of Boeing, Lockheed Martin, and in Japan, Mitsubishi Heavy Industries. In our space and defense segment, again, motion solutions for applications such as satellites, launch vehicles, missiles, ground vehicles, and submarines. And so the major defense primes tend to be our customers. And in our industrial segment, again, critical and reliable motion control solutions for applications such as in power generation facilities, industrial machinery, test equipment, and even Formula One race cars. So moving on this slide, I'd like to share Moog's current activities in Japan. Moog Japan was established over 50 years ago in 1970. The facility is located in Hiratsuka City in Kanagawa Prefecture. Moog Japan currently supports the following segments. So for Moog Industrial, a range of electro-hydraulic and electromechanical actuation technologies. They're used in markets such as power generation, industrial machinery, trains, and specifically it's the bullet train for sway control, and also test systems. In aircraft, Moog works with the commercial airliners such as JAL, ANA, and for military aircraft, the Japan Air Self-Defense Force through the respective primes and representatives. And in space and defense, Moog supports the Japan Self-Defense Force by supplying servo valves used in applications such as torpedoes and specialty actuators for ground vehicles. So I'm now going to shift to Moog Australia and what we focus on. So firstly, Moog Australia, we're the headquarters of Moog's Space and Defence Group in Asia Pacific. We're established in 1979, and we had a new facility that was built in 2014 with an expansion which completed in April 2021. Our facility here has an optimized lean layout designed for supporting precision motion control systems to be used in defense applications for air, land, and sea domains. We run an AS9100 quality management system. Moog Australia's mission is to be the centre of excellence for defence control systems across air, land, and sea domains. And this is accomplished through development of local IP, which is then turned into hardware designed, produced, and exported within the region and ultimately globally. So in the defence sector, Moog systems are found on critical applications where safety, reliability, speed, and accuracy are essential. So for example, in the air domain, we supply weapon management systems, fin control for missiles, vibration control and slip rings for rotary aircraft, and flight control actuation for UAVs. On land, remote and turreted weapon systems, precision motion control for gun laying, stabilization, and ammunition loading. And at sea, critical actuation for naval ships, submarines, and unmanned underwater vehicles. So as you can see across all domains, our expertise is in platform weaponization and critical actuation. In both Australia and Japan, Moog is positioned on many defense platforms employing these critical actuation systems. So if we focus on the specific components and systems that Moog designs and produces, towards the left-hand slide, or the left-hand part of the slide at the component level, where the company started, we specialize in valves, motors, motor controllers, actuators, and slip rings. And in the middle of the slide, where we're showing the integrated subsystems, examples include gun turret motion control systems, radar motion, and underwater vehicle, again, motion control systems. And on the very right hand of the slide, at the system level, we have weapon stores management and integrated platforms. So at Moog Australia, we support the Australian Defence Force across a range of platforms. These platforms cover air, land and sea domains, with some of these examples provided on this slide. Specific to turreted weapon systems, Moog Australia undertakes the sustainment of the ASLAV and M113 gun turret drive systems. And these are the ground vehicles that you can see pictured on the right-hand side. We also build actuators and control systems for naval ships in Australia, used for fin stabilization. So in the land domain, which is one of Moog Australia's core areas, we're focused on the following technologies: turreted weapon systems and integration. We have stabilized motion control for turrets, launchers and radar systems, remote weapon operation and fire control. And this includes a lightweight remote weapon station currently under development here in Australia, counter unmanned and aerial system solutions, complex defense automation, such as ammunition reloading and ammunition handling, ultra high-speed directors for active protection systems, and lastly, converting old hydraulic motion systems into electromechanical motion. And this conversion could include speed, stabilization, and safety upgrades. Here, sharing a bit more technology related to turret driving and control systems. So turret driving and control systems include dual axis controllers, elevation and azimuth actuators, gun control units, slip rings, fire control computers, and various motors. Our heritage spans programs like the ASLAV armored fighting vehicle, the M113 infantry fighting vehicle in Australia, Stryker Bradley vehicles in the US, and the CV90 in Europe, as an example. And across Moog, we've delivered over 13,000 axes of control. The flexible missile platform. So this is one a system where we are looking very actively for partners to work with. Moog's flexible missile platform, or FMP, this is a missile mission and platform agnostic solution. So what this means is once the FMP is integrated, it actually allows the user to fire the missiles of their choice from the vehicle of their choice. So our FMP, this is a combination of Moog's stores management technology and our expertise in military motion control and stabilization. And as we are missile mission and platform agnostic, we're looking for partners to work with for the missiles, the sensors, and the vehicle supply. Just some more details here of our FMP. Up in the right-hand corner, Moog's technology is the section in red, which is the pedestal with motion control and stabilization capability. So we're looking for partners to work with for the missiles, the missile launchers, the sensors, for example, the electro-optic sensors, and also the platform the FMP can be mounted to, whether it's a manned vehicle or a UGV. So in summary, Moog Australia's focus is to work with companies and organizations in Japan, specifically around defense targeted weapon systems. The Australian designed and manufactured options will be non-ITAR and non-BAFA. And as we touched on throughout the presentation, technology include the maintenance, repair, overhaul, upgrade, and product lifecycle extension of defense motion control assets, customized weaponization solutions for air, land, and sea assets, for example, the flexible missile platform, turret and weaponization upgrades, both manned and unmanned, and tailored kinetic response, for example, the ultra high-speed motion for active protection systems and smoke launchers. Ultimately, our goal is to deliver solutions to our customers and end users to provide tailored overmatch against our opponents. So now this concludes my presentation. Thank you very much for your attention.
Thank you very much, David. And I'd like to welcome our third speaker, Dr. Joshua Cho, for Explore Space Technologies in New South Wales, and you are the CEO of that company. Go ahead, thank you.
Thank you. This up. Okay,
hopefully everyone can see this and hear me okay. Hello, everyone. Thank you again for the opportunity to be able to come and share what we do here at Explore Space Technology. I think it's going to be a very different topic that you're more accustomed to. Even though we're space technology, we're in a very different space, so to speak. What our company do is really looked at developing solutions and technologies with anything to do with humans in space, the human element of space. For today's presentation, I'm going to focus specifically on an area that we find quite exciting, and hopefully you'll find that quite interesting. So why do we say space is a new frontier for health? And it's really because it provides a very unique environment in which both materials, and of course we know the human body responds differently too. And what we've been doing here at Explore is really to leverage that technology and that environment, or specifically microgravity environment, to help us develop solutions to address a lot of the healthcare concerns we have down here on Earth. So we are the world's first, and if not the only one, space biotech company right now, translating a lot of those technologies and solutions to address all the healthcare needs down here on Earth. So what makes space unique in terms of, for healthcare? And it's really because microgravity is a different environment. It's a remote environment, it's an extreme environment, and it's no different than if you were to do research in Antarctica. I always tell people, if we suddenly put you in Antarctica, you're going to feel cold, and that response is what we really want from space. So over here in this picture, you can see an illustration of cells. So this is the basic building block of our human body. Cells on Earth can function properly, but when they're in space, they respond very differently. We all know that, for example, astronauts lose a lot of bone, and that condition is very similar to diseases on Earth like osteoporosis. So in essence, our body, our tissue, our cells change, but we don't understand how or why. And that's what we've been doing here at Explore, is to develop those technologies to help us understand that. So on that note, the platform we have made is we call BioGravity. It basically recreates a simulated microgravity environment. We've developed this about 5 years ago, and for the last couple of years, we have been using it to advance a lot of our understanding in terms of the human biology. So for over here, you can, on the right, you can see that, in breast cancer, we can see a lot of difference, also in lung cells as well. So we've applied our technology in a number of different diseases and organs together with our partners from around the world. We're very proud that this year, we won the Good Design Award, Best in Class in the engineering category for the remarkable innovation we've done in this area. So you can see that using our simulated microgravity technology, there is endless applications that it has anything to do or associated with the human biology and human healthcare. So today I really want to focus on 3 key areas on drug development, drug discovery, and of course, cosmetic tech and aging disease treatment. So the first thing people always ask is, what is the applications? If there's any successful case studies, and I want to share 2 of those big success studies of how new drugs were developed using microgravity technology. So the first one, as I mentioned before, osteoporosis. This is an aging disease that is faced by everyone. There's no cure for it currently. So during my time at Harvard Medical School, I worked on the project together with NASA and Amgen, which ultimately developed into this anti-osteoporotic drug. You can see that there is significant growth. It's still continuing to grow. And this was really using that microgravity environment to help the drug company identify the pathways and the mechanisms of how bone remodeling happens, and using that to develop this key drug. The other drug that is also very successful and leveraged the microgravity environment is Merck's Keytruda anti-cancer drug. So this, before the development in microgravity, it brought in about $3 billion a year in revenue for Merck. And this was really troublesome for the patients because it took 12 hours to infuse this drug into the body. So you can imagine sitting there for 12 hours having this drug. It's really not pleasant, and it's very time consuming. But because they put this drug in microgravity, the properties of the drug change. And rather than 12-hour infusion, it went down to a 1-hour infusion. And this has skyrocketed, of course, Merck's revenue, and also, of course, benefited directly to the patients themselves. So these are two classic examples that I always use to show people that there are tangible, translatable applications of using microgravity for drug development. So where is our advantage compared to others, and why? And I know a lot of people are thinking, well, if it's that great, why aren't more people doing it? And that's because, you know, to send things into the International Space Station, the actual space is very time consuming and also very expensive as well. So it doesn't really open a lot of opportunities for, you know, more traditional type of companies, especially for exploration or development. Using our technology, it is much more affordable, and we can be ready in days. And of course, the number of samples you can use is a lot higher. So what we've been doing is also to help launch providers in terms of optimizing experiments before they go on the ISS for experimentation, but similarly also help industries, especially the biotech sector down here on Earth, to conduct advancement and development here on Earth. And they don't really require that environment of the International Space Station. So in terms of drug development, we have utilized and leveraged our ability to understand the accelerated aging process to help us in drug discovery. So we have combined this with AI machine learning for high throughput screening of drugs and to understand different diseases. And we have been quite successful in terms of breast cancer, in which our platform has demonstrated to identify 7 new breast cancer drug targets that have never been used or identified before. They were drugs that were associated with diabetes and cholesterol, and through our platform, we were able to identify that. So we see a lot of potentials in combining AI machine learning together with our microgravity platform, because on Earth, a lot of these pathways in diseases or models can't be turned off, and they can only be turned off in the simulated microgravity environment. And we've demonstrated that we're able to deliver on that. The other project that we've been working and focusing on is the cosmetic industry. This is a very, needless to say, a very big and lucrative industry, especially the regenerative cosmetic. So there are some statistics. These are very well recognized and established markets. Specifically, we're focusing on the stem cell market. So right now, there's the emergence of stem cell conditioned medium. I was in Japan in the Cosmetech earlier this year, in which there are some companies that are producing these raw stem cell derived medium for different type of cosmetic applications. However, these are all produced under static conditions in which the stem cells aren't really stimulated. So if you think about producing these stem cells in a like a static environment, there's nothing really to stimulate them to release more of these growth factors. However, using our technology, we've seen a significant multiple fold increase in the release of these critical growth factors and cytokines compared to conventional methods, because what we're doing is stimulating the stem cells in a way that we can be able to harness those core ingredients and biomanufacture it so that we can package it for cosmetic regenerative procedures. So, right now we're in the process of, building this up and scaling it at a large scale so that we can have an established pipeline for large scale biomanufacturing of these conditioned mediums for cosmetic regenerations. The other a spin out of that has really been to work with existing stem cell companies. We acknowledge that this is an area that we're good at, but there are a lot of great products, especially around stem cells, that are out there. how do we help them? So we've actually worked on a licensing agreement with a lot of stem cell companies, both in Australia and also the United States, in which we're able to help existing established biotech companies to increase or improve on their existing formulas. And this has been, we have been getting a lot of positive results from that. And we see this as a big market because there's quite a lot of stem cell companies out there, and we recognize there are a lot in Japan as well. And that's why we're establishing our footprint in Japan to be able to support and get more people to utilize our technology. And finally, what we're also working in is the microbiome therapeutic products. What this means is that really in biomanufacturing. If you think about it, there are a lot of medicine, lots of growth factors, and a lot of things that we normally use that is made of bacteria and fungi. And you can see from the pie chart, a significant portion of that biomanufacturing really comes from bacteria. Where you will see this cutout from Forbes, the global biomanufacturing capability is hitting a peak. And now everyone is looking at ways, innovative ways in which we can increase their production, because we've actually, again, hit a peak. So applying our microgravity technology, we've actually seen a 200 to 300% increase in the bacterial growth. This is actually quite significant. And recently, with talking to a global biomanufacturer, that is something that has never been heard of. So what we're doing now is really to work with them. And in the US, we're working with a US company on the production of insulin. But you can imagine there are so many applications and products and solutions that are derived from bacteria. We haven't even had the opportunity or the time to look at the effect on fungi. So this is a very big market. It's a direct, accessible market that we can be able to access now. And it's not something that needs time or to develop in the future. So in terms of our team, we have offices here, obviously in Australia. We're based here in Sydney, Australia, and New South Wales. We have an office in Michigan University that's managed by Dr. James Seacrest. He handles the US side of operation. We also have a team over in Tokyo as well. Mr. Takashi Okubo, he was the chief financial officer for Takeda Pharmaceuticals. And we also have an ex-JAXA engineer working with us. So we've already started our footprints in Japan. And right now we're just talking with the local biotech industry to really establish how we can help them, support them, and to start the biomanufacturing of a lot of our products and solutions. So, doing all this is obviously, not a single company can do. We're very privileged and honored to be working with world-class research institutions and companies. Specifically in Japan, we work with Mitsui and also a lot of the space companies in Japan as well. And of course, globally with a lot of the world-leading research institutions to help us really push the science and for us to translate that science and knowledge into something that is clinically relevant. So thank you for your time. I hope you found this interesting, and I sincerely look forward to hearing your thoughts. Feel free to reach out to us and our team. Thank you.
Thank you very much, Joshua. That was fascinating and terrific to see that you already have a footprint in Japan. Well done. So I'd like to introduce company 4, Chironix, from Western Australia. And the speaker today is Daniel Milford, founder and CEO. Go ahead, Daniel.
Thanks for the introduction. Just give me one moment, I'll pull up my slides. And for today, I have enabled your ability to actually provide me some feedback as I go through the slides if you have any questions with audience tools. So if you go through the discussion day and you want to actually interact with me, you can actually access that site as you see in the top of the slide there. And that would actually then give you the relevant channel back to me. But I am the founding CEO of Chironics. My name is Daniel Milford. My background, I was a defence public servant and military officer, where I also worked in technology enablement. And that led to me forming Chironics in 2017. And over the 5 years of operation, we've already released one major product with Google X called Medics on Google Glass. We've scaled to 40 staff, and I've done a restructure back to the high 20s now, as we focus on one of our principal product offerings that's coming up for the future and currently released in beta form to key customers called Pilot OS. And it's that I'll be presenting to you on today. In addition to that, I'm honoured to actually be here and be representing the state of Western Australia, where I've been resident for the last 6 years. So without further ado, I'd like to give you my presentation. The mission of Chironics is really to build a future where humans and robots can work seamlessly together so that we can leverage the best of the robotic platforms and the best of our existing human workforces. And to be clear, when I'm talking about a robotic platform, I'm actually talking about a physical robot in the field. Now, we're partnered with Boston Dynamics, where you're probably familiar with Spot, and have been partnered with them for 4 years. We're also partnered with a range of other companies, AgileX, ClearPath Robotics, Canadensis. And effectively, we work in robotic vehicles from the size of a small Land Cruiser, so a light vehicle fleet and below, to do two things: to monitor infrastructure and information, and secondly, to move things around a site that's important to those users. So in Chironics, we make these robots useful to humans through developing critical key software and enabling systems integration of relevant payloads on board so that those robots are useful to our customer base. We really are working hard towards a future where humans and robots are synchronized in their activities, because the problem we're solving is how to easily introduce robots into existing workforces without fully displacing the existing human workforce. We're providing productivity and safety enhancements to our customers from introducing these technologies to really give that existing human workforce a capability advantage in their utility values. And we're really doing that through naturalistic forms of communication and that software that enables the value of that vehicle to that base team. So Pilot OS is our principal product, which enables this human-machine teaming arrangement to occur. And we've been developing it over the last 2.5 years. We're currently in the beta phase, where we're working with major primes globally, and we're going to be releasing a full commercial solution just in the coming months. So our progress to date: we started working on Pilot OS 2.5 years ago with significant defence support from Australia and the United States with the US Marines, DARPA, and some other customers. Through that time, we decided that we really needed to focus on an agnostic platform, which could then allow for a sensor base with our software to be put on multiple different types and models of robots. The reason for this is because some robots are legged, some robots are wheeled or tracked. They range from about 1 meter in size all the way up to the size of the vehicle. And each of them has different performance characteristics: how far they can travel, what they can carry, and really their operational forwarding capability, how they move across the terrain. To date, we've integrated 7 major different types of robots, and the list continues as our customer base increases their demand. And we have around about 28 different types of models of robots, which we currently resell with further enhancement on our systems. Now, we've been working very heavily in the utilities sector, in government, mainly in military logistics, in oil and gas with offshore monitoring, and finally, and mainly in resources and mining, in doing a whole range of activities. And those use cases have allowed us to develop really clear vertically aligned opportunities to support businesses. In addition, we've got custom payloads, which allows for the utility of the vehicle to be maximized. So thermal cameras, acoustic imaging systems, and other necessary systems that our customers require. All of this is done with one real vision, and that's to improve the availability of the existing workforce to make them more productive and safer in what they do as a job. And we support that workforce that's actually out in the field doing the day-to-day activities as required. Currently, We can successfully move a range of robotic platforms through our stack through a whole range of complex terrain. We have been working with military customers in dynamic terrain that's heavily mobile. We've been working in utility sectors, as I mentioned, with simple missions, which we would call teleoperation. You have a vehicle anywhere in the world, you can log into it and drive it around manually and see what's happening. Automation is actually where we say, oh, we want you to actually go over here, and you're currently here, you find your own pathway. So that's, again, a lot of the military work that we've done. And complex missions is actually where you do pre-planned programs, routes, and for the robot to make its decisions about how to best maneuver throughout the demands on it. Currently, with our beta customers, we're now rolling out the surveillance packages for resources, oil and gas, condition monitoring for other assets, and automated maintenance activities as well. So there's a large vertically aligned packages of work that we've done here. So at a glance, PilotOS allows you to track all of your assets in a single space, all of your robotic fleet systems, and we're all now introducing the human workforce elements to it as well. You can manage them in time and space, control their activities, and task and perform relevant tasks. Finally, the sensor-based systems and payloads that run on those robots can all be fed into our PilotOS system, which allows you to see live information from that robot base. And that's really because we're trying to achieve the 4 things down below. First of all, we're trying to increase the safety of the human workforce by exposing the robots to any dangers as necessary. We're trying to increase the productivity of the total operation of the workforce, including the humans and robots, by having the humans do the complex work and the robots doing the boring administration, mundane work, which they're really good at. We also can scale very quickly. Once we have a known use case that works, then we just apply many more robots to that use case, which gives the company that we're supporting a significant advantage to move fast. And finally, we're maximizing the availability of the existing human workforce, which is greatly in demand, and it's challenging to get them. So for a visual representation of what we do, it really breaks down to these 3 key areas. We do hybrid teaming. As you can see in the GIF on the bottom left-hand side, you have a mine worker that's walking through an explosive pattern. They've just got some blast cones, and there's a whole range of other use cases here. He turns and naturally puts his hand up, which tells the robot to stop. He's going to access the payload there and lay out those cones. And from there, turn around and do the gain symbol. So he'll put his hands out to the side, and the robot will start following him. So this is a natural form of visual communication between the robot and the human, where it allows them to team together. The robot carrying the payload, the human doing the work. And we've been scaling a whole range of use cases, not obviously just with dropping blast cones, but with detonators on a whole range of other activities on mining, oil and gas platforms, and mainly in defense as well, with casualty evacuation as one of our premier areas. The second main key vertical for us is the teleoperation. And this is for the manual control of robots anywhere in the world. And finally, the mission planner, which allows you to basically pre-program routes and automated routes for those robots. The advantage that we have is we're agnostic to the base platform. Our module sits on any robot that has a CAN bus interface and allows us to command and control it and integrate it into our total stack. So our customers have complete optionality with what the base system is and a single federated environment, which is PilotOS, to see and control them all. We also then support the customers with their workforce on the ground to naturally interact with those robots. So we've provided the full trinity of control and command of these robots. So the key use cases as we sit and as our customers require of us are really in delivery of payload. You can see here with weapon testing areas, we've been retrieving spent munitions that are under testing, and autonomously the vehicle is driving 15 kilometers back up to the firing point to provide it, removing human workers from that activity. Other areas in mining is we're delivering core samples and soil samples from the mining face all the way back to the chemistry and analysis sheds, as just one of a few examples. For inspection tasks, we have inspection robots in a whole range of utility sectors, in mining and oil and gas sectors, and they're really there to do fixed asset monitoring, condition monitoring, and make the human operators aware of any maintenance that's required. Hybrid teaming is that key element that we deploy in all of our robots to sense and experience the environment and move and navigate successfully in it while being able to communicate naturally with the human workforce. And finally, fleet management, that ability to work agnostically with a whole range of different robots. Now, we have been working with a whole range of government research entities, academic institutions, and key major customers, big multinationals among them. And this is just a very small snapshot of the large cross-section of companies and organizations that we work with, and the list continues to grow. So I'm honored to be able to present to you today. My apologies it was so brief, but my personal information is available there, and our corporate information is below, and I look forward to hearing from any of you in the future.
Thank you very much, Daniel. I love the idea of robots doing boring and mundane work for me.
Don't we all?
Sounds great. Thank you. And over to Queensland now, to Gilmour Space, headed up by David Jervis today, Head of Corporate Sales. Go ahead, David. We'll move on to Masaki Takahara, who is the Managing Director of Jetro Sydney, for his final words. Thank you, Takahara-san.
Sari-san, thank you very much. Let me share the screen. Yep. Hi, my name is Masaki Takahara, Managing Director of Jetro Sydney. And thank you very much. Thank you for joining us today. Let me just talk about the post-event survey. When you exit Zoom, a post-event survey will pop up. If you'd like to have business meetings with any of the 5 companies, please select that option in the second page of the survey form. And we will arrange meetings under Jetro's JBridge program. Also, if you have any comments on the webinar, please feel free to write. Your feedback is highly appreciated. In case the survey form doesn't appear properly, we will send you the URL for the survey later, along with the URL for downloading today's speaker's presentation slide. So please use that as well. Now let me introduce JBridge program briefly. JBridge is a business platform to facilitate the collaboration or alliances between Japanese companies and innovative Australian companies to develop the business overseas. Jetro supports cross-border open innovation for accelerating digital and green transformation. Specifically, we will provide JBridge member companies of Japan with information on promising overseas companies, support for business meetings with the companies, and support for strategy formulation and business development through experts. JBridge will open opportunities for foreign startups companies to meet Japanese companies. If you are interested in this service, please contact with Jetro. Thank you very much. Over to you, Sari-san.
Thank you very much, Takahara-san. So we hope to continue with the Nichigo JBridge events next year as well. It's been a terrific way to introduce Australian companies and tech over a variety of sectors to Japanese partners for potential collaboration. And thank you to Jetro Sydney for providing the platform for us to do so. Please reach out to Jetro, to Takahara-san, to the state offices, or directly to today's speakers if you would like to further conversations or have any questions answered. And we look forward to continuing with you in 2023. Thank you very much and goodbye.